4 years ago, I did a video on space heaters. The video was basically about what is the best space heater, and I got hundreds and hundreds of comments on this one thing, which is 1500 watts is 1500 watts is 1500 watts. The point I think most people were trying to say is if it uses 1500 watts of power, then it's producing 1500 watts of heat. So no space heater is really more efficient or effective than others. And while I understand this claim and think there's some validity to it, I thought it'd be fun to test it out and see if this is actually true. So really, I want to answer the question, is a big space heater any better than a small space heater? So I got 5 space heaters. 2 of them I would consider to be quite small, and 3 of them I would consider to be fairly large. And for my experiment, I woke up every morning at 4:30. As soon as I woke up, I would go upstairs to my upstairs bathroom. And the reason I would go there is this is the only room in the house that does not have a heater vent. So I'd plug in a space heater to a smart socket so I could measure the wattage. Then I would turn on the space heater for exactly an hour and a half. I would close the door and I would leave the door closed for 4 hours and measure the temperatures based on the fact that the space heater was on for an hour and a half. So I put together this spreadsheet. Now I have a weather station outside that I can use to get the outside temperature. And the reason I did that is I measured the temperature at each hour from 4 to 7 to get the average temperature. I did this for about 7 days, so about a week. And then I used Google's forecast function to basically predict what the temperature in the bathroom should have been if I did not turn on any space heater. Now you can see that the actual average temperature is different from the forecasted, but it should be pretty close. But you can see here, there's a variance of up to 0.7 degrees. So obviously this is not completely accurate, but it's the best I can do with what I have. To show you how I use this spreadsheet, let's look at the large space heater. So I measured the temperatures 3 different days, and I got the temperature every hour with the space heater being on from basically 4:30 in the morning to 6 o'clock in the morning. So you can see how the temperature goes up. This is always the highest temperature right here because that's when the space heater has been on the longest. So you can see from 64.9 to 73.4, so almost a 10-degree difference. So the average temperature here about 70 degrees here, but if you use the forecast measurement, that means if I did not turn on the space heater, it should have been about 61 degrees. So that leaves an 8.9 degree difference. Now, if you look at this column here, I use my smart socket to determine that it used 1.6 kilowatt hours of power. So if you divide this by this, then that comes to about 5.5 degrees per kilowatt hour. So the important column here to note is the degrees per kilowatt hour, because this is basically saying if I use this much power, I can heat up the room this much. Now again, conditions aren't perfect. I only did 3 days per space heater, but using this data, we can see a few interesting things. The first thing I want to look at here is the tower space heater. That is the one that got the hottest at 77 degrees, and the large infrared heater that had the highest temperature of about 69 degrees. And so if we look at degrees per kilowatt hour, you can see that the tower space heater did the best job at heating up the room for 4 hours with an average of 6.33 degrees per kilowatt hour, whereas the large infrared heater heated up the room only at 4.19 degrees per kilowatt hour. But things are kind of weird. I think with the infrared heater, it was a bit of an anomaly, because if we look at the average, here I took the average of all space heaters, and the average, the large tower had the highest average temperature, whereas the large infrared heater had the highest average temperature. But if we look at degrees per kilowatt hour, the large infrared heater was actually the best at 5.52 degrees per kilowatt hour on average. Now this is because it used so much less power than all of the other space heaters. And then the small infrared fireplace heater, that was the lowest of the bunch with an average of 4.77 degrees per kilowatt hour. So what are some things I learned running this experiment? The first obvious thing was that the results were somewhat inconsistent. If we look at the large infrared heater, on these 2 days the highest temperature was about 71, but on this day it was only 69, despite the outside temperatures being on average warmer than the other days. So I have no idea why this would be lower, but on average this is still the most effective space heater as far as heating up the room while being on for 1.5 hours goes. The one reliable statistic seemed to actually be total kilowatt hours. You can see here, consistent across each space heater with a very slight variance only on one, where it's off by 0.1 degree. So that's the good news. I can actually reliably measure how much power each space heater is using. Which brings me to the next thing I learned doing this experiment, is that just because a space heater is a 1500 watt space heater does not mean it uses 1500 watts of power. Running the space heater for an hour and a half, the large infrared space heater used only 1.2 kilowatt hours of power, whereas the small Fireplace heater and the tower space heater, they both used about 1.7 kilowatt hours of power. And these are both 1500 watt space heaters. So take that for what it's worth. Just because you're buying a 1500 watt space heater doesn't mean it's going to use as much power as, say, another 1500 watt space heater. Another thing I learned is the space heater size does not really have a significant impact on how much power it's using or how much heat it puts out. Here, the largest tower space heater is using 1.7 kilowatt hours of power, and so is the small Fireplace heater. The small ceramic desk heater is using about the same as well. So yeah, size doesn't really make a difference. The last thing I learned is that space heaters that have like fans or displays on them, the power consumption for running the fan is completely insignificant. So I actually did a test with one of the space heaters where all I did was turn on the display and the fan, and I measured the wattage for having that on for an hour and a half. And you can see that it actually used 0.01 kilowatt hours of power. So don't be afraid to get a space heater with a fan on it thinking that it's going to use more energy. It does use some, but nothing significant. So what are the conclusions I've come to after running this experiment? First thing is that price and size for a space heater does not make a significant difference. You can spend a lot on a space heater or you can spend very little, and both space heaters are probably going to work about the same. So to answer the question, does size make a difference for a space heater? Not really. My final conclusion with space heaters is basically the same conclusion I had in the last video I made, which is you should get a space heater for the functions and designs that you like. So when would I recommend an infrared space heater? I have a space heater like this that I use in the garage. I like this because I can put it right up next to me and it warms me up nice and well. I also have a space heater like this that has a fireplace. It has a fan, so it's kind of loud. So I don't like using it in a bedroom, but I do have it set up in our living room. And around Christmas time, our family would read Christmas stories around this and kind of pretend it was a fireplace, and it had kind of a nice feeling to it. Ceramic space heaters can be really nice because they're so small, or they can be so small. I recommend this in areas where you need something portable or just a personal space heater put up right next to you. Most of these do have fans, so they can be kind of loud, but the one I got to run this experiment, I was really impressed with. Despite the small size, it worked just about as well as the large one did. I've used oil-filled space heaters in the past, and I really like these for if you want to maintain a certain temperature in the room. It does take longer for these to warm up the room, but once they do, they maintain the temperature really well and they're nice and quiet. And I like mica panel space heaters because they heat up an enclosed room really fast, but they don't have a fan, so they are nice and quiet. I hope this video helped you some. Thanks for watching. Have a great day.